Hi, this video tutorial about the famous data structure stack. So that is a very familiar data structure. So I am Senthilkumar, Associate Professor, Computer Science Department, Panimal Engineering College. So let us see. So this session we are going to discuss the concept of the very popular data structure stack, and we are going to define what is stack and the basic operations of the stack and how the stack is implemented, and finally we will discuss numerous applications of stacks. So this is a one-way car parking model. So all the cars which come inside the parking is parked into the car park. What is the appropriate model for representing such a model? Is a suitable one is stack. That is, the first the car which come here, the next one, the last inserted that is a parking car is taken out, that is the next one is out, like that. So there is a very popular data structure stack, that is the last inserted or added element is taken out first. So what is stack? So it allows the insertion and removal of the elements only at one end, what it is called a top of the stack. What is a top of the stack is, that is a stack pointer. The new item are added to the top of the stack, what it is called the insertion. So this procedure is called as a push, and the items are removed at the top of the stack is also called as a deletion. So that is called the pop operation. This entire push and pop operation will take in the form of last in first out. That is a LIFO. Okay, that is very example for the stack of books. So I am going to explain how this books into the. So I am taking a 5 books here. So how it is added one by one. First I put into the first book into my stack of books. Then second one, third one, fourth one, and fifth element. That is the stack which consists of 5 elements. The last inserted book is taken out from this book of stack. So then next one, like that, because stack is a linear data structure, all the elements are added and removed in the linear fashion. So your stack is restricted linear list in which all addition and deletions are made at one end, called the top of the stack. So look up this, some of the representation, stack of coins, stack of books, and the computer stack, the elements are added one by one, what it is called a push, and the last inserted element it will be taken into the out, that is called a pop operation. So what is called data structure stack, ADT, some of the typical operations, abstract data type here for the operation which you are going to implement, create. First you have to create a stack, it create a empty stack, then push operation, pop operation, top. This push and pop are primitive operation. Other than that, we are going to represent the top, that is a topmost peak element. Then we are going to check the two condition, whether the stack is empty or whether it is a full. Okay. First we are going to discuss about the push operation. To insert the element I into the stack S, because we create a stack S, then pop operation, it remove the top element of the stack and return the removed element as a bounded value. Such a way the top, which return the top element of the stack. So why we are going to use the is empty condition is, whenever we are going to remove the element from the stack, first you have to check whether the stack is element is available now. If it is empty, it will be returned true. So then if it is false, you can remove the element from the empty stack, such a way for full. So when you are trying to add the element into the stack when it is full, you have to add further element. So this is a stack which we created. Look up this here. We create a stack in the name of stack name. This is an empty stack, there is no element. The push operation is insert the item at the top of the stack. The following show the format: push the stack name followed by the data item which we are going to. Here the example which show that adding the numbers, okay. The stack before push, there are two elements, 20 and 78 are added. So the top element which pointed to the 78, what is called stack pointer, okay. Then we add the new element 30, that is whenever you are adding the element into the stack, what it is called a push operation, that will be added into the, that is the top will be incremented to 1, top equal to top plus 1, then automatically the stack pointer will be incremented. Now it is now the stack consists of 3 elements after inserting the 30, 20, 78, 30. So what is pop operation? Pop operation nothing but removing the elements or deletion the element from the stack. So first you have to point the top element into the top of the stack, find the top pointer, then pop the item which pointed to the stack, that is the 30, which is removed. After removing the 30, the elements on the stacks are only 20 and 78. So what is the operation which you have performed here is to decrement the stack pointer top equal to top minus 1. So this is an example which is showing the segment of the algorithm, which yearly we are discussing the push and pop operation. First we create a stack in the name of S, that is a empty, then adding the element 10 into the stack S. So look up this here, then one more element we are adding 12, then the stack consists of 2 elements 10 and 12, then we will check the condition if before going to remove or delete the element from the stack, we want to check whether the stack is empty. That is what the empty, this is one of the operation. So empty of whether if it is not empty, we are going, if it is not empty, then we pop that. Pop of that, that is after popping that, the topmost element will be removed. Then the next operation is push the new element 2. Now this is a stack. After pushing the element 2 into the stack, the 2 will be added into the, now the stack consists of 2 elements 10 and 2. So next one is how to implement the stack. How to implement the stack? You can implement the stack data structure using list. A list may be array list or it may be a linked list. So what's the difference between array list and a linked list is, array is a static data structure, whereas linked list is dynamic. So it is a fixed one, whereas a linked list is a dynamic one. That is the size of the stack is given initially before going to use. But linked list, it's never become because it's a dynamic. You can add how much you need it. It's a dynamic in nature. So this is a abstract data types. After element 5 elements are added. This is a consider that this is a one ADT abstract data types. That's a consist of the stack which consists of 5 elements. So this is array implementation. There are n element which are added into the stack, and such a way linked list. In linked list, each node have 2 elements. One is for adding the element, another one is pointing to the next node in the list. Such a way we can create the linked list. Let us discuss the next topic is application of the stack. So where we are using stacks. So we started with the definition, what is a stack, and push and pop operations, and where we are using the stack. So there are a number of applications we are using. Conversion of number system. So all the number system which were converted from decimal to binary, hexadecimal to binary, etc., and a function call within the programs, and evaluating the arithmetic expression such as infix to postfix expression conversion, postfix evaluation, and the balancing the symbols, tower of Hanoi problems, that is one of the mathematical puzzles, and the 8-queen problem also, so the gaming problem. So let us look at the any one or two applications. We started with the conversion of number system. So this is a very famous one. How to convert the decimal number 26 into binary number system. So we will take 26 as a decimal number. Look up this here, 26. We you know that how to convert the decimal number, that the decimal number divided by 2, then it will take 2 stacks. One is for quotient and another is for remainder. So divided by 2, the 13 is a quotient, the remainder is 0. Then again this number is divided by 2, the quotient is 6 and the remainder is 1. Such a way, all the remainders are pushed into the remainder stack. Okay, the remainder memory stacks. Such a way 0, 1, 0, 1, 1 like that. So this is what the remainder stack after divided into 2. Then these elements will be, so that is a push into the remainder stack. After the remainder 0 is pushed into the stack 1, then 1 is pushed into the next element, 0 is next, 1 is next, like such a way. After inserting all the element into the stack memory, remainder stack, now we are going to pop to print the equivalent binary number. That is the topmost remainder element from the stack is first one, then the next one, then 0, then next. Such a way 1, 1, 0, 1, 0 is the equivalent binary representation of this decimal number 26. So this is the algorithm. Look up this here. The algorithm which convert the decimal to binary number, the purpose is to print the binary equivalent of the given integer, that is absolute value. The given integer to be converted, that's a precondition. What's the precondition is given the integer to be converted into number. Okay. Post condition is the binary integer is printed, that's after the result. Okay. So this is the algorithm. We create a stack S. The given number not equal to 0, that's the number which you are given to, for example 26 we are given, then as usual the number will be divided by modulo 2, the remainder will be stored, then the remainder will be pushed into the creator stack hash, then the next time the number will be again divided, not equal to, as long as it's going into that, all the remainders are pushed into the stack. After pushing, if all the elements are pushed, now we are going to pop. When you are going to pop, there is a precondition. Okay. If the stack is not empty, then you can pop the element from the stack. That is the element which you are inserted the X from pop. Then the element will be printed. That is what discussed here in this example. Okay. So that is the algorithm for what is that? Implementing the stack operations by using converting decimal to binary. So there is another application, Tower of Hanai. That's a mathematical puzzle, famous mathematical puzzle, which we are going to discuss here, Tower of Hanai. So we will have a model. Before going to discuss this model, we will discuss what is Tower of Hanai. It's a mathematical puzzle which consists of 3 towers. Look up this tower 1, tower 2, tower 3. And the also called as a X, and more than one ring is as depicted. So these are all the rings. There is some precondition. These rings are different sizes and stacked upon a ascending order. That is, it's in the like ascending, smallest to largest. The smaller ones sits over the larger one. There are other variation of the puzzles where the number of disk increases, but this is very important. But the tower count remains the same. Only 3 tower, you can increment any number of disk. So what is the rules for solving these puzzles using stack? The rules follow here is only one disk can be moved among the towers at any time. Only the top disk can be removed. No large disk can sit over the small disk. That's rules. So one more notable here is the Tower of Hanai puzzle with the n disk can be solved with a minimum 2 power n steps. That is, if you have a 3 disk 1, disk 2, disk 3, that is a n equal to 3, 2 power n minus 1 steps. That is a 2 power 3 minus 1, that is a 7. So 7 movement only you can do and complete that. Look up this here. Representation shows the puzzle with the 3 disk has 2 power 3 minus 1, that's a 7 steps, you have to complete that. So this is algorithm which will show with this model. So let us see that how this model is working. We have 3 towers, that's a Bex, that's a source, a destination, and the third one is an auxiliary tower. So we have here 3 rings here. Okay, we will move all these 3 rings into the destination disk by using these steps. That is by using the recursive algorithm of Tower of Hanai. So initially the procedure has 4 parameters. The procedure name is Hanai. disk, the number of disk is 3, and the source is the source tower, and we have a destination and axillary. If there is no disk, then move the disk from source, that is the source is the destination. Else, if that this consists of more than one disk, that is the disk is not more than one disk, that the else part may be working. We started with here. In our example, we have a 3 disk and 3 towers. So that's a procedure, recursive procedure called here disk, that is a n minus 1, 3 minus 1, that's a 2 disk from source to destination. Here now the destination is by through the axillary, that is the destination is act as the axillary and move into the destination. Look up this, the first step is move n minus 1 disk from source to axillary. So I moved here from this one to here destination, move from source to destination. Then the second disk is move into the axillary, because that is a n minus 1 disk from source to axillary. Then from destination disk to the axillary. Then the next, after the completing of this step 1, the next is move the disk from source to destination, that is this one, move this disk from destination. Now come to the third step, we have a disk n minus 1. Now these parameters are changed. Look up this here, source is changed into the axillary now, and also the axillary is changed into destination and the source is destination. So what is the next one is we move the disk n minus 1. Now let us move from here. Now the source is axillary. The source is axillary. So move from axillary to the destination disk as n minus 1. So this one, and move from next step with disk from source, because it is axillary is now act as a source, move to the here. Okay, that's a, then finally we move that from the source to destinations. So there are 7 steps which you complete. Okay, from the recursive algorithm of here the tower of that will take the 4 parameters, disk, number of disks 3, source, destination, that's the temporary axillary. So now with the 7 movements, this will be moved from source to destinations. So that is what the tower of bustles with the n disk can solve the 2 power n minus 1 steps. So we take 3 disk, 2 power 3 minus 1, that is a 7 step we solve this problem.